Hey everyone, this is Chris back again with the Ancient Scholar, and I'm going to continue talking about the pulmonary toxicity or general concepts of pulmonary toxicity. Okay, so we talked a little bit about the compartments and a little bit about the basic physical characteristics of agents and what are some things that can affect the absorption of these agents. We talked about size, airflow. We talked a little bit about when the size gets very small, less than about a micrometer. Then we have to look at the water solubility, the chemical reactivity, and the actual dose of the agent. There are many other things that go into the where the effects will be, the breathing pattern of the person. There are other any underlying physiological issues as well. Kind of comes into play. So it is fairly complex, but I think we got the big high yield points out of the way. Okay, so what can we do armed with this knowledge? Well, what we can do is we can kind of look at the major effects. All right, we can look at the major effects and we can classify them. We can say that we have agents that have major effects in the conducting. Okay, in the conducting airways. We have agents with major effects in the diffusing airways. All right. And then we can also have agents that have more systemic effects. And what I mean by systemic is that a lot of agents, they may cause damage to the lungs, but they are absorbed and they have profound effects in the systemic areas of the body. So in other organ systems, other tissues, what have you. It's just not isolated to the pulmonary system. And we'll talk about what some of those agents may be. So what we do is we will say that agents whose effects are more or less limited to the conducting airways. Obviously, there's some caveats. Large doses, for example. If you inhale a large dose of something, it's not going to be limited. But just in general, just to help better classify these agents, we can say that those agents are type 1 agents. Agents that primarily affect the diffusing airways. We're talking about the alveoli here. We can call these the type 2 agents. And then agents that have more systemic effects, or effects that are not limited to type 1 or type 2, we can call those the type 3. And we say this with the knowledge that we know that it's not nearly as simple as this, but this is just kind of a way of looking at those agents. Agents are seldom pure type 1, type 2, etc. We know that. Okay, so I can't really talk about every agent that there is, but let's just talk about some major ones. So let's talk about, I think what I'll do is maybe I'll try to use some different colors. So let's do yellow here. Yellow. All right, so let's talk about sulfur. Let's talk about sulfur mustard. All right, so sulfur mustard, since that's a major agent, particularly we talk about the history of chemical agents. So sulfur mustard, you can say sulfur mustard acts in the conducting, acts both in the conducting and the systemic. All right, conducting and systemic. So sulfur mustard, okay, so sulfur acts as both a type 1 and type 3 agent. Sulfur is kind of an interesting one. In fact, it has a weird nature about it where it's not particularly water soluble. it's more lipophilic, but the sulfur that does interact with water is actually turned into a highly reactive ion, and that's where you can get type 1 effects. And then we also know that mustards, sulfur, nitrogen mustards, have profound effects when it comes to DNA. And so you can get some pretty significant systemic effects when it comes, certainly when it comes to the immune system, immunological effects. In fact, that's we actually use mustards in some of our chemotherapeutic agents for cancer, because we know that cancer cells are rapidly dividing, and when cells are rapidly dividing, they're undergoing cell division. Their DNA opens up, and it's very prone to being damaged when that occurs. So it makes sense to administer drugs that are based on these that can damage DNA in susceptible cells, and cancer cells just tend to be more susceptible to that. Okay, so we could say that sulfur mustard is primarily type 1 and type 3 effects. All right, and then let's move down to the next major agent. We'll make that purple. What the heck? And we will say phosgene is the next one. So, okay, phosgene. And phosgene is primarily a diffusing airway. Okay, so it's primarily type 2. So I'm going to put phosgene right here. All right, primarily has its effects in the alveoli. All right, and then we will move to make this blue chlorine. All right, chlorine. Chlorine has a combination. Okay, chlorine is combined, and it's combined primarily type 1 and type 2 effects. So we'll go chlorine. All right, chlorine. Now we know that chlorine is highly reactive, so we would expect more type 1 effects at lower doses, and then type 2 effects will occur at higher doses. All right, and then another one, make that red, another example might be something like cyanide. All right, where cyanide has significant absorption through the pulmonary tract, but its effects are certainly not isolated to the lungs, and its profound systemic effects, because it causes decoupling of oxidative phosphorylation, and systemically affects your cells. So certainly cyanide would fall under the type 3 effects. Okay, so I think that's a pretty decent way to look at it. What are maybe some other agents? Well, like smoke particles, like heated smoke and heated ash, and larger particles like that are certainly primarily going to be more type 1. We're going to have more type 1 effects. Let's see here. Your polycyclic aromatic hydrocarbons, you can run into those. The PAHs primarily going to have type 3 effects. So PAHs, I'll throw them there. Acrolein, like lubricating oils that have overheated and have vaporized, turned in. You're going to have some type 1 and type 2 effects there. Let's see if I can find another color. There we go. So we'll put... All right. right, just trying to throw some examples out at you there. Okay, I think that's pretty good for now. You know what? Now let's just throw a few other, because there's some industrial chemicals that I think are kind of important as well. So let's see. Another one might be ammonia. Ammonia is going to have, for the most part, it's going to have type 1 effects. All right. Ammonia is a good one. We talked a little bit about cyanide. Hydrofluoric acid, hydrogen fluoride, it's highly reactive, like ammonia. It's fairly reactive, so you would expect more type 1 effects with that. Let's see, maybe another agent that can kind of have multiple effects. Lewisite. Yeah, lewisite's a good one. Let's see if I can. Lewisite is going to be really good at having type 3 effects. So it's going to have systemic effects in addition to type 1 and type 2. All right, so it's going to have pretty significant effects. Let's see, carbon tetrachloride, another industrial agent occasionally run into. Carbon tetrachloride, let's see here. Yeah, what the heck, we'll make that nice orange. Carbon tetrachloride is an agent that's going to have some type 2. So CCl4 and then CCl4. Okay, there we go. I think we're good. I think we've talked about several agents, industrial weaponized agents. I think we're good to go there. Some of your military smokes, like I said, are going to have more type 1 effects. Clearly, as you get more toxic, so white phosphorus, red phosphorus, more dangerous, you're going to have more pronounced effects. You could even have like hydrocarbon smokes that are going to have type 1 and 2 effects. So a lot of different variation going on there. Okay, so let's now go ahead and talk just a little bit about basic pathophysiology. Change the color back to black here. There we go. All right, so when we talk about damage to the central compartment or the conducting airways, okay, the primary pathophysiology is you're going to have large masses of cell debris. All right, you're going to have mucus production, okay, and some inflammatory components as well. And there's where you're going to run into most of your major problems with those type 1 agents, okay? Your airways are going to fill up with masses of dead cells and lots of mucus and lots of inflammatory changes. And this damage is generally the result, like we said, it's generally your more highly reactive substances like chlorine, so it's generally direct. It's direct chemical. All right. It's direct chemical reactivity. Okay. And oftentimes you're going to have acids. Gosh, my handwriting's terrible today. Acids being generated. So, for example, hydrofluoric acid is very strong acid it's generated when when hydrogen fluoride comes in contact with the airways. Your peripheral your peripheral or your diffusing, okay, your peripheral or diffusing airways are going to be a little different. Generally, this will be the result of chemical changes in the agent. The agent actually changes, and you have the development of free radicals. All right, free radicals, okay, of which reactive oxygen species would be um, a subset of free radicals. So free radicals and ROS are going to play a big role in the pathophysiology of peripheral of the diffusing compartment. So what do we have here? In the peripheral or diffusing compartments, these free radicals damage the epithelium of the alveoli. So you have compromised. All right, you have compromised alveolar capillary membrane integrity. Okay, what does that mean? Well, that means that the hydrostatic pressure inside of the blood vessels, all right, hydrostatic pressure is going to push fluid, okay, is always, hydrostatic pressure always acts to push fluid out of the vessel, and now you have a compromised alveolar capillary membrane integrity, so hydrostatic pressure is going to push fluid out from the blood, from the vascular compartment into the lungs, and your major complication that you're going to run into is pulmonary edema, all right? In addition to loss of surfactant, atelectasis, and inflammatory changes occurring in the alveoli themselves. All right, so those are some of the major damage. So what's going to happen? Well, you have this large obstructive pathology occurring in agents that act up here, whereas you have a more inflammatory pulmonary edema, adult respiratory distress syndrome, or ARDS kind of pathophysiology occurring there. So your central or conducting airways, you're going to have things like wheezing, coughing, sneezing, hoarseness. You're going to even have stridor possibly. Of course, if you have significant stridor or carbonation sputum, your patient appears to be compromised in any way, or you're worried about burns, you would really want to worry about early intubation in these particular patients. The diffusing compartment toxicity can be very very stealthy in its appearance. These patients can actually may not have marked symptomology right away, and they can have delayed onset. In fact, that's kind of a classic or a key finding with this, is that you have this delayed, okay, you have this delayed onset dyspnea, or you have this delayed onset dyspnea, and your initial, okay, your initial exam may be rather unremarkable. All right, their saturations will be good. Their ABG won't be particularly concerning. Their workup will be pretty unremarkable. You do a chest X-ray, it looks good. You don't have any indications of pulmonary edema, and maybe they get discharged, and then they end up either returning or having a adverse event at home, possibly even death. So that if you ever suspect some sort of chemical exposure, and the patient tells you that maybe they were exposed a few hours earlier and now they're having these problems, that is really something that you want to key on. This is a very kind of concerning situation, and the delayed onset dyspnea really should kind of key you into, okay, maybe something's going on here. And perhaps you would actually want to admit that patient, or watch them for several hours and do serial chest X-rays if their dyspnea does not improve or gets worse, so you can detect the presence of the developing pulmonary edema, and of course you'd want to do a cardiac workup in that to rule out acute coronary syndromes as possibly being related to that. So certainly there are some other differential diagnoses to consider, but certainly delayed onset dyspnea after inhalation exposure, particularly if you know the agent involved and the agent is known to have class 2 effects. Okay, guys, I think I'm going to go ahead and just cut it off here. And I'll see you guys next week when we start talking about our blood agents like cyanide. As always, thanks for hanging in there.